Hello, good morning, and actually good afternoon to folks on the east side. And thank you, Chris, and I would like to thank Blaine as well for moderating the session, Nilo for the excellent coordination you have done. And I think before we go and talk about the communications from a connected vehicle perspective, I would like to really thank the National Operations Center of Excellence. I mean, a few years back, who would have imagined that we will have 165 people and we'll be presenting, sitting in our offices and exchanging this great dialogue. So kudos to NOCO. So I know this has been covered, but I just wanted to share this high-level V2I system diagram just to illustrate that the infrastructure systems, which are on the left, and the vehicle systems, which are on the right, have to collaborate to support the cooperative safety and mobility applications. So for a meaningful V2I system, the connectivity between the RSUs, or also called RSCs, on the infrastructure side, and the OBU, the onboard unit, also referred as OBE, on the vehicle side of the system is required to enable communications dialogue between the infrastructure and the vehicles. And without such connectivity between RSU and OBUs, the V2I system is essentially incomplete. Therefore, I will focus my presentation more on the right side of this diagram. And from an agency perspective, I would like to say that at least from the agencies that are just deploying the SPaT challenge, it may be beneficial to incorporate in the design and implementation the vehicle subsystem, fundamentally to support testing of their infrastructure deployment, verifying and validating the infrastructure messages. But in a long term, this will also help in preparing for larger fleet deployments in the future, so that they can implement applications such as transit and emergency vehicle priority. So from a definitions perspective, OBU is a vehicle-mounted device. The primary function of OBU is to receive and transmit messages to vehicles and infrastructure over the air through the DSRC, the Dedicated Short-Range Communications. So this has been covered earlier, but I would like to draw the difference between OBU and aftermarket safety devices. I think they're one and the same. The only difference is that aftermarket safety devices are not integrated during the vehicle manufacture process, but added after sale. They do have some more software capabilities, and that's something for the agencies to look into when they go through their procurement.
Faisal, could you speak a little bit louder? We have some issues hearing you.
Okay, I will. Thank you. So for the purpose of this presentation, we will use the term OBU. Is it better?
Yes.
Okay, so this plot diagram is just an example of a simple application that provides phase state information to the drivers through the driver vehicle interface, which is on the right. So just to illustrate the function of OBU, which receives and decodes the SPaT and map message over the air. It also receives the vehicle position information from the GPS receiver, or it can be from the vehicle CAN, which is a controller area network. It uses the positioning information to perform lane matching and transmits the phase state and the signal timing information for the match lane to the driver vehicle interface so that the driver gets that information. So this kind of illustrates the various functions that the onboard unit performs in terms of both receiving the data, decoding it, some processing in terms of the lane matching, and then transmitting the information to the vehicle. RSUs and OBUs are very similar in terms of most of the functions, but there are some differences for the agencies to know. Typically, both of them have two radios, but some early versions of the OBU had only one radio. In terms of the specifications, RSU has a standard specification from US DOT, which is 4.1, the latest one, but there is none, or there isn't one for OBU yet. In terms of the FCC licensing, for RSU, the licensing is required, so agency has to go through the licensing process. So there will be a webinar in the future that will be discussing the various aspects of licensing. As far as the OBU is concerned, it is up to the vendor to get the license, so the agency is not responsible for the licensing. Obviously, in terms of installation, RSU goes on the infrastructure side and OBU on the vehicle side. The power inputs are different. For the RSU, it is power over Ethernet, while for the OBU, it's 12-volt DC power. In terms of the cost of OBU is lower than the RSU, but the cost kind of varies based on the quantity, and that is something that you work with the vendors. Here is just a block diagram of the various subsystems within the OBU. It consists of DSRC services, a GPS receiver, Ethernet port to support graphical user interface, so that, as you can see, it is connected to a tablet for visualization. It has USB ports for data logging, operating system, interface. As you see in the box at the bottom, there is an interface to the controller network for the vehicle, and also it can include the Wi-Fi routers. So at the bottom, you also see the connections to the antennas. So the two DSRC radio connections and one for the GPS. And there are several manufacturers that supply the DSRC units. I don't have all of them here. This is just to illustrate that there are several vendors out there. What I like to point out is that the OBUs are becoming more and more of plug-and-play installation, so the technology and the installation process is getting better over time. So what is the role of OBU in the SPaT challenge? I think number one and most important is for the agencies to really know whether the roadside unit is broadcasting the SPaT and map. So in other words, agency may look into having a test vehicle, which is installed with an onboard unit that will support in knowing if the SPaT and map message are actually being broadcasted. It will also provide confirmation if the messages broadcasted from the intersection are transmitted as per J2735 message set, if they are accurate, if the encoding and decoding is proper, the payloads are correct, things like that. Also, it will help the agencies to know if the message is delivered within the required range of the vehicle. We have a direct experience in our test bed where the range for some of the radios was really short, and without having the test vehicle, we wouldn't have known the issue. It was resolved between the vendor and our integrator, but that was really very helpful. Then the verification and validation of messages. will also ensure correctness of information transmitted from the infrastructure to the vehicle, and also provide confidence that the OEM implemented applications such as red light violation warning are operating correctly. As a matter of fact, as Blaine shared, there will be a very specific webinar on the topic of verification and validation process, and I encourage you to attend that one. And in the long run, it will help the agencies to learn, and then as they employ their own applications such as EV priority applications, transit priority applications, they will have a good idea of the onboard unit operations. Some of the installation considerations, our experience is mostly on buses and fire trucks, but in general, as compared to RSU, the OBU installation in a vehicle is relatively simple. It will be preferable to provide to the vendor the details such as IP addresses in advance, so that the vendors can properly configure the OBU. This also saves time for the agency, so the vendor doesn't have to spend too much time out in the field. It's good to engage your IT departments. In terms of installation, simple installation includes just connecting the OBU power to the cigarette light or source, placing the antennas on top for better coverage. The installation on larger vehicles such as fire trucks and buses is more challenging, and in those situations you may have to engage technicians from the equipment services. They have to provide the power source. For example, when we started installing on the fire trucks, we quickly discovered that the fire trucks don't have a cigarette lighter socket, so you have to create a power source for that. Performance aspects, positioning, accuracy, the SRC range, and the other aspects, that too will be covered in the future seminar that I talked about earlier. But I think it is important for the agencies to know that there are no guidelines available for installing the OBUs in a permanent way in an agency or fleet vehicle. However, we do have some good examples of the installations done by some of the agencies who have been early adopters in installing the OBUs. And I'll start with our experience here. So we have our own incident response team. So our project has been focused, initially we started focusing on emergency response priority. So we equipped some of our React vehicles. Here's an example. On the left, we installed the OBU right under the back seat. And the power source, as I said earlier, was installed by our equipment services. The antennas, the two antennas on the top of the vehicle, these are the shark fin antennas. But that's why I put a question mark there. As you can see, it's sort of permanent, works okay, but I think it's not a finished final product. So there is a need to come up with some guidelines in our industry, so that we all have some idea of how to make a more more stable installation of the devices. There is an example of installing the radio, the OBU, and the antenna on the fire truck. As I said, it gets more challenging. You have a lot of equipment. You have ladder. You have occlusions. So here is our University of Arizona team, and this is a temporary installation of antennas on the fire truck. This is an example from Caltrans. They have been installing OBUs and also RSUs for a long time. They're probably one of the most experienced agencies. They have worked with different models of OBUs, and I don't want to go into the details, but they're using different channels, and also the Caltrans team has been heavily involved in the development of the software, like our team here with the University of Arizona. So they do use SDK, which is a software development kit. They're not connected to the vehicle CAN. From their experience, they say that the OBUs with 2 radios work better than with single radio, particularly for applications that utilize multiple DSRC channels. As I said, they have very extensive experience in managing, writing, debugging, and processing scripts on OBU, similar to what our University of Arizona team here. So if you're looking into application development, both of these will be good resources for your developers. They find that SDK is very useful. In addition to the capability of developing and running your own application on the OBU, SDK includes sample applications to help users, developers better understand the OBU platform. Caltrans also suggests to log error status of key processes into files and regularly check the log files and make corrections. Again, this is more like a developer type of application. And finally, from their experience, the new OBUs meet the 2016 version of the standards, and they're becoming more like a black box to the users, which is really good. This is again for some example of Caltrans installation. So here they're installing it in the trunk of the testing vehicle, which is the picture in the middle. They are using the magnet mount antennas on the vehicle roof near the windshield. And as I said earlier, for example, in our case, earlier on we installed the antennas on the driver's side of the bus, and our reception was not that good. And I think what Caltrans is saying is that if you install near the windshield, then you get a better signal reception. That picture is on the right side. They get the power to the OBU through a power inverter, which is the picture on the left. We have also started using the power inverters, so that's very helpful. Especially, I think one of the lessons we learned from a demo perspective is in our test vehicles, we keep 2 OBUs, and just in case if something goes wrong, and then we have the power inverter, the battery, so we can quickly switch the OBUs. One of the challenges from the earlier version of the OBUs was the reboot, so that's another reason to have a battery source for the power, because it takes like 5 to 10 minutes to reboot OBU. But I think I was talking to some of the vendors, and it seems that this problem has also been resolved. Now the reboot takes about 30 seconds. Here's an example from UDOT, and if I say something wrong, Blaine, help me here. So this is a good example of an operational system where probably one of the first agency or the first agency to have a transit priority system operational on the corridor. They have a nice cabinet in the bus, so it works very well. As you can see, on the very right side is the closer view of the installation in the cabinet. They have a BeagleBone Linux computer, which is running the MITS application and the power supply. From their example, DSRC installation was pretty simple, but the challenges came from the installation of the antenna. They tried several things before getting it to work consistently. The big concern was to avoid penetrating the bus exterior. They found a place in the shroud near the top front of the bus. You can't see it, at least in this picture, unless Blaine points out. The shaft is a fiberglass, and the placement here has worked very well. I think one of the things they suggest to keep in mind is that these are external installations, and these vehicles go for a wash on a nightly basis, so they get beat up easily. So you don't pay a lot of attention how to install the antenna so that it's not impacted. So this is a good reference. I just thought I'd share. So the New York pilot, New York City pilot, they had a RFI for ASD, and they wanted to learn what is out there. So there is a link at the bottom which you can use. You can Google it. It's a really good document to take a look if you're interested in OBUs or ASDs. This is one of the examples from the New York City pilot. They again installed the antenna. I think they also had the same challenge as UDOT, and this is the installation right in the middle of the windshield, and that seems to work very well. So if you're looking just from a SPaT challenge perspective, I think a simple installation would work. So just get your OBU, hook up to the cigarette lighter. You can use the magnet antennas, and with the plug-and-play OBUs that are available now, it should be pretty easy and should take like a couple of hours. As I mentioned, if you have the right IP addresses, it should work well. Some of the lessons learned from the installations. To understand how the full V2I system works and to verify and validate the RSU messages, we do recommend that the agencies include OBU systems in their procurement. I would suggest that at least have one or preferably two of the OBUs just for verifying the SPaT challenge messages. I think this will make the SPaT challenge more meaningful. One of the things to consider is the visualization application. Some of vendors provide that so that you can visually see how the messages are flowing and where if the accuracy is correct, if the range is correct, things like that. However, I think there is a need nationally for a generic visualization tool that can support all SPaT deployments. The in-house planning, pre-planning is very helpful. And finally, I would end by saying that there is a need for a procurement spec for OBU. Perhaps it can be done through a CV pilot project. As I said, we'll have a separate webinar focused on performance validation. And I think with that, thank you for listening to me.